gotta watch it. Okay, here we go, my beautiful calculus students. Say hi to me.
Hi.
All right, that works.
Favorite person.
All right. All right, well, we're going to sketch y equals 2 to the x. And I want you to label the points that I asked you to label. Okay, so somebody give me some points that are on this graph. 1, 2. 1, comma 2.
Negative 2, 1, 4.
Negative 2, and then what?
1, 4.
1/4, which isn't up very high, is it?
0,
0, 1. This is my favorite point right here, just to let you know.
3, 8.
3, 8, yeah, I don't know as if that's really going to happen. Here's 2, here's 3. 1, 2, 3, 4, 5, 6, 7, 8. We're just going to pretend that's 3, 8. Any others? Can you think of any? Those are the 4 I asked for.
Negative 1.
2, 4.
Okay, what did you say? Negative 3, and then 1/8. I could do that over here. Negative 3 and then 1/8. That's really kind of small, 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 small. Okay, negative 3 and then 1/8. What else?
Negative 1, 1/2.
Negative 1, 1/2. I heard you say 2, 4.
Yep.
Okay, so no room to label that one, so I'm just going to say 2 and then 4. All right, so this graph should be nice and smooth, right? And you can tell I didn't have an XY axis. Oh, nice, Gina. Okay. And I heard you guys talking about having a what over here?
Horizontal asymptote.
Okay, so we're going to have a horizontal asymptote. What's the name of the horizontal asymptote?
The x-axis. Oh, y equals 0.
Y equals 0. It is the x-axis, but the name of the x-axis is y equals 0. Or the equation of the x-axis is y equals 0. Okay. What else do we have here? I asked you a couple more things. I asked for the domain. What's the domain of this function? All real numbers. From negative infinity all the way over here, all the way to positive infinity. Now, I noticed, I walked around and I saw every single one of your papers, I noticed that at negative 2, 1/4, some of you stopped. And you didn't have an arrow, the graph didn't continue. Just because I asked for those particular points doesn't mean you don't go beyond those points. Doesn't mean you don't connect those points. Doesn't mean there aren't an infinite number of points on this graph. Okay? All right, I know I want my range. All real numbers again?
No. It's going to be from...
From 0 to 0.
Parentheses 0 to positive infinity. No, it has to be an open parentheses because it can't be 0.
What's it? What do you say? It can't be 0.
Y can't equal 0.
The y can't equal 0 because we said y equals 0 was going to be a horizontal asymptote, which means the function is getting closer and closer and closer to, but never actually touching. So y equals 0 is not going to be a point on this function right here. So how do I want to write this then?
Open parentheses.
Open parentheses.
0.
0, comma.
Positive
Infinity. Okay, very good. I'm going to write it like that. Okay? Just because I like the idea of y is greater than 0, just keys me in real quick to the fact that I am dealing with range because I'm using y. But I would take, definitely, open parentheses, 0, comma, infinity works just as well. Okay, this bugs me that this isn't nice and smooth, so try to make that a little nicer. Alrighty, so we have everything we need for this function. I'm just going to write y equals 2 to the x. Now, another reason why this graph will not touch the x-axis and will not go below the x-axis, or another way to think about it not doing that, is the fact that my base is a 2. And it really doesn't matter what the exponent is, whether it's a 0, positive, or negative. I'm never going to get a negative number or a 0 out of this as a possible power. Right? So for instance, if you took 2 to the first, you get 2. If you take 2 to the second, you get 4. If I took 2 to the 0, I get 1. If I take 2 to the negative 1, I get 1/2. All of these are my powers, right? If I took 2 to the negative 2, I get 1/4. These powers, these answers that I'm getting when I take the base of 2 and raise it to any exponent, these answers can't be negative because my base itself wasn't negative to start with. Okay? So, and we're not going to be playing with anything other than positive bases because that's what logarithms are defined for, positive bases. So we're only going to have positive bases, which means our answers are only going to also be positive. Got that? Okay, so no matter what x you use, the answers, the y values are always going to be positive. This means y is positive. All right. So that being said, recall from your pre-calculus class that there was a 4-step process to getting an inverse function. Do you remember that?
I remember that there are.
First step was to take your f of x and make it a y, right? I'll put these over here, but I'm going to erase it, okay? So change f of x to y. Second step.
Switch the y and the x.
Switch the x and the y. And I used to say interchange. Do you remember that word? Interchange x and y? Okay, what about third step?
Solve for x.
Solve for what?
A y.
Because by the time you interchange x and y, it's going to say x equals something. So you're going to have to solve for the other thing, which is solving for y. And your very last step, replace what?
Replace y with x. Or
With what?
f prime x.
With what?
Was it with
What are we trying to find?
f prime x or f of x?
It's
Say it louder. F inverse of x. You get this calculus all mixed in here, right?
Yeah.
Yeah.
All right. So this is a 4-step process to what? To calculate the inverse function. All right, and now we're going to come over here and we're going to calculate the inverse function. So I'm going to pretend like I started with f of x so that I can do my first step. What do I get? What do I do now? Quick.
Y equals 2 to the x.
Y equals 2 to the x. Next step. Hurry up.
X equals 2 to the y.
Now I need to solve for y. You see how solving for x wouldn't be this next step? Because it's silly, it's already solved for x. Solve for y. Am I going to get y out of the exponent? Use your noggins.
you have to root of y.
How do we get an exponent down?
Do you have to do a logarithm?
Say it louder.
You have to do a logarithm?
I have to do a logarithm. I've got to get that log involved in order to pull that exponent out. Right? So I could do two things. I could take the natural log of both sides, which I really don't want to do. I just want to take this, it's in exponential form right now, and switch it into logarithmic form. All right. What's my base here, by the way?
2.
2. Okay, so when I do log, it's base 2. If you want to put a little scripty thing, I don't want anybody to think I'm playing with a z there, okay? Log base 2 of, hey, by the way, we learned last year that a logarithm is an exponent, okay? So a logarithm is an exponent. What's the exponent? Y. The power goes here, which is a what? X. Okay, so now we have solved for y. Y is equal to log base 2 of x. All right, last step.
Replace y with f inverse.
I like to make those 2's fast, don't I? Okay. So f inverse is called log base 2 of x. Now, I really don't want to graph this just from log base 2 of x. No.
Why?
The Oreos are safe for math team. If you want to go to math team this afternoon and have competition, then you can go and get an Oreo from there.
On the skid.
All right. So, but thanks for asking. I appreciate the concern. Okay, so log base 2 of x. Now I want my inverse functions. I want to build my inverse function from the original function right here. How much time we got?
None.
Okay. So I want to build my inverse function from this. How do I take this? I don't need to know anything about this to draw my inverse function. What do you know about all your inverse functions? Yes. What? What's that mean?
Because
Y
y
equals
equals.
your x's.
Just change the y's and the x's. Okay? So what do I have? Yeah, there is. What is that line? What are you talking about?
Line of symmetry?
Line of symmetry. What is the line of symmetry
It's
between
called-
any function and its inverse function?
No, y.
The x-axis?
Y equals x.
That's the
Y equals x. Yeah, good. A little squeak comes out of it. Okay. So this is the line of y equals x straight up through quadrant 1 and 3. Okay, so I know I'm going crooked here. I'm sorry about this. My perspective is off a little bit, and I don't want to run into all that stuff. Give me a point that's on the inverse function.
Oh,
Zero.
Was it
1,
4, 2?
0.
I heard 4, 2 first. Here's 4, 2.
10 minutes is on. 2, 1.
2, 1. So 2, 1.
You said 10.
Okay.
You said 10 to 12.
Hold on. What?
1, 0.
1, 0. I like this point right here. If I like that point, don't you think I'm going to like this one?
That's our level.
Okay, 1, 0. 8, 3. Here's 4, 5, 6, 7, 8, 1, 2, 3.
2, 1.
I BS that just a little bit. What is it? 2, 1. I already got it. You blind?
Oh, sorry.
Paying attention?
I was plotting points.
What else we got? 1/4, comma, negative 2, 1/4, negative 2. Good job. Hey, what's happening here again? I have a horizontal asymptote and we're approaching y equals 0.
So for the inverse, there's a...
Say it louder.
So for the inverse, it must mean there's a vertical asymptote of x equals 0.
That makes sense, doesn't it?
Yeah.
You see how this graph is going down, 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 down? Plus, don't the domain and range switch when you do inverse functions? So now my range will be all real numbers and my domain will be x is greater than 0?
Yeah.
Okay, so this gonna kind of make it hopefully look nice. If it doesn't look nice, we're gonna, I don't know, cry. Just make your dots a little bigger. The idea is there, that's what we're trying to get across, okay? So now we have a vertical asymptote here. We have a vertical asymptote of x equals 0. I have a domain of what?
X is greater than 0.
X is greater than 0. Just interchange the x and y. Your range should become your domain should become your range. Okay, so so x is greater than 0, sorry. And what about my range?
All real numbers.
All real numbers, because this graph will continue to go down to what number? Down, down, down. Negative infinity. And this graph will continue to go up and up and up. It doesn't continue to go up at a very fast rate, but it does continue to go up forever and ever and ever. Takes you, I mean, you got to move over a lot to the right just to see a little bit of growth in your height, but you continue to have growth in your height. There is no horizontal asymptote capping them out right here. So this is going to go, range is going to go, our real numbers. We good with time? What's the time on it?
12.
Okay. So we're going to stop this right now. This is the equation here, f inverse of x equals log base 2 of x. And we'll start our next video in just a second, okay?
Gotcha.
All right. Talent out. Say it.
Talent
out.
I was waiting for that.
You're waiting for that? That's cool.